So product integrations within the context of digital manufacturing solutions means incorporating software platforms, different data sources, and also different technologies and products to make sure that we have a full scope of the manufacturing industry. And that is basically the core of Industry 4.0. So some of the trends driving the needs for product integrations within the digital manufacturing landscape is, first of all, smart factories, making sure that we leverage from the IoT capabilities that we have, sensorizing the machining floor to make sure that we get real-time data from the machines and use that data to enhance the production process or even do preventive maintenance. Another topic connected to it is edge computing, making sure that we gather the data from the factory floor and the machines, and then so that we can make the changes and improvements close to the factory floor in real time. So it doesn't have to take a long period of time for us to make improvements, we can do it directly. And another trend is robotics, to make sure that we can have lights out manufacturing. A lot of companies do that already. We do it in our production facilities in Gimo, and we see that coming on at a larger scale in various types of industries. Another trend would be the digital twin, making sure that you have a digital replica of your product or even of your machine to see that the production process, how it flows, if there are any risks or if there could be any quality constraints by doing the process in the way that you had planned before you reach the factory floor. So I think digital twin is one thing that we have done quite well lately, and it's an imperative part of integrations to make sure that you can visualize your product earlier than on the factory floor. And integrations such as integrating product information into CAM systems and other types of verification systems will make that process easier for us. Another one is the robotics movement. We have seen it for a while, but I think that robotics is becoming more relevant nowadays. And we are an example of that within Sandvik Cormont with our Gimo facility, where we have more or less lights out production around the clock. So predictive maintenance is becoming more or less the norm, using IoT and other data-driven insights to have historic data as well as real-time data to predict what's going to happen next. And in that way also make sure to overbridge any issues or any quality constraints that could come. So some of the key benefits in product integrations is to reduce the human interaction and make sure to predict the workforce needed for a process. Another one is increasing the product quality, and that is by introducing robotics to reduce human errors as well as doing the repetitive tasks with robots. Another one is the operational costs connected to it. By knowing what your production is going to cost, you also can have more predictable operational costs. Another one is enhancing of the supply chain management. By knowing what your production is going to produce and consume, then you can also make sure that your supply chain management is up to date. Integrated solutions enhance the collaboration and communication amongst different departments because they overbridge the information gap. By having the same data presented in various sources will help us to take informed decisions in the right way. Product integrations enhance the usage of data that is presented in different sources. By using reporting tools and different types of predictive maintenance using both real-time data and historical data will make sure that we can take informed decisions closer to the issue when it arises rather than waiting for a while and then figuring out what to do. Real-time data plays quite a huge role for improving the efficiency and then the production process, because you get the data when it occurs, and you get the chance to analyze it and then prevent that from happening again in real time. And that is crucial for this fast-paced industry. Our industry is going through a lot of change in a short period of time, and we need to be quicker in making decisions. So the challenges that may arise is that different data sets from different suppliers or different platforms cannot talk to each other. So one thing to overbridge that is to make sure to map out which data needs to be integrated. Sometimes we tend to integrate everything because we will use it at some point later on, but mapping out and knowing what you're going to use the data is the first step. The other step is looking into the vendors and seeing which type of data they can accept, which type of data they send, and making sure that those structures are in place and the architecture are compatible. Another more important topic is to make sure that the service contracts that the vendors provide are in line with our expectations. Because you might need support at some time, it's good to know what we have. And the more data we exchange, the more cybersecurity becomes more important. And I think that's something that we need to take into account when we're looking more and more into integrations. So some considerations that can be taken into account is not doing everything at once. Starting with a modular architecture to make sure that you can add on features and modules as your need grows. We tend to do everything at once, and that's not a winning concept. Another one is using cloud infrastructure to leverage from everything and the scalability that cloud infrastructures have, where it's applicable for us. And then a third one, from my perspective, is the documentation. We tend to integrate, but we don't document, so we actually don't know what's been integrated and why. And the last one is the security and the compliance. We work in a global environment, but we have a lot of compliance to take into account and security issues. So that is a key aspect to make sure that the integrations stand over time, but also are secure when we're using them.